Hi, Miss Priya.
Hi guys. Okay. Here what I see is most of you are done with your algebra 2. Good to know. Okay. Shaker, what are you doing in school, Shaker?
Oh, me?
Yeah.
Um, we're doing exponential and log solving.
Exponential and log solving. Maybe we should do a little bit of it and then move on to pre-calc is what I'm thinking. Let's see. So we were working on, let me quickly check. Start of log functions and affecting exponential functions and linear models. Okay. Okay, maybe we'll work on some more logarithmic problems. See, because the same thing is going to come in pre-calc a little harder. So we'll see that. Rishit, what are you doing in class, Rishit?
At school, we're doing expo and log solving.
Solving. Okay. Okay, so we did till 8:35, right? So let me quickly go over. Okay, so we already got started. Looks like we are on 8:35. Graphing logarithmic functions is one. Okay, graphing and then understanding transformations is one. Other than that, we can do some word problems as a part of SAT, SAT prep, and then we can get into some. Let's see these. Let me go ahead and do this. Okay. Let me share my screen, guys. Okay. Let's see. Coming to 8:35 till I have already done, but I just want to know how about this. Okay, thorium 230 is a radioactive chemical. Is a radioactive chemical. Okay. Now, the percentage of thorium 230 remaining in a sample after T. The percentage of thorium 230 remaining in a sample after T time T will be equal to 100 2 power of minus T by 75 1 2 3 75,000. Yep. Let's say how long has a coral reef been growing? The oldest portion. Okay, let's see. This is the P of T is a function that talks about percent of thorium 230 remaining in a sample. Okay, now how long has a coral reef been growing? How long has a coral been growing? If the oldest portion, if the oldest portion has, try this, if you don't know I'll do, has 1.5625 percentage of thorium 230 remaining. Yep. Let's try, guys. Let's try. I want to see how each of you do this problem as well. There are a couple of ways to do this though. Are we confused on this? Algebra 2 Friday 6 to 7. Correct. Okay. Would you be able to do this? How are you doing it? I want to understand, guys. Subi, Akshada, your videos are not on.
Miss Priya, I'm outside. It's okay if I'm not.
Sorry, ma, I didn't hear you. Wait. What, ma?
I'm outside right now, so is it okay if I have my video off?
Sure, ma.
Thank you.
Good job, Rishit. Did you convert to log or did you not? Rishit, did you convert to logs?
I'll do that.
No. I'm asking how did you do that? That's all.
Oh, so
Did
since
you?
it's like a decay thing,
Yeah, did you
um,
convert to logs or did you retain it in exponential function solved as two function? How did you
I
do?
retained it in exponential.
So you solved it at two. You solved it at two different functions. You solved it as two different exponential functions, Rishit.
Yeah.
So let me go ahead. If you're able to do all of this, then I'll go ahead and do some SAT-based problems on the same topic, and then we'll move on to. Let's see. I'll either move you all to pre-calc or do a little bit more on SAT-based problems, then move you to that. Let's see. Yeah, I got Avni. Yeah, Avni, that's correct. Subi, did you get it? Shrikar, did you get it? It's just more of a plugging pasting, but I just want to understand where are we doing on that.
I think I almost got it.
Uh-huh. Let's try this one. Actually, you know what? I had the same thing for the other class, but I had given them some SAT material for that. Why don't I go there? Quickly check. Give me a minute. And the problems were a little hard too. So why don't I do the same thing here? Let's see. Yeah, see. Oh, this was really good actually. Okay, let's go ahead and try this. Because earlier it was difficult for them. Okay, we'll do at least 5 problems on this. Did you finish? Shrikar, did you finish?
Yeah, I'm typing my answer.
What is it? Shout out.
I got 450,000.
Okay, that's good. Yeah, that's correct. So let's go ahead and do this one. See, these are all subtle, harder, not the school based problems. A biologist observes that a culture of bacteria doubles every 45 minutes. Initial population is this. Oh, yeah, let's see. So, which equation models the population after T hours? Uh, so, here, what is making it harder is the minutes and the hours. That's right, Arush. Arush, that's correct. Akshata, that's correct. Shrikar, waiting. Avni, correct. Avni, why the confusion, Avni? Yeah, Shrikar, that's correct. Did you get it? Subhi, Akshata, did you get it?
Yeah.
Yes, no. Subhi, it's not that, right? So here, Subhi doubles every 45 minutes, right? This is T hours, right? So basically you want it as hours. So 800 is the starting point, all has 80. Doubles, that is the base. But then the exponent has to be in hours or seconds. However, they want it after T hours, right? So it would be like 45 minutes you have to convert it, right? So 45 minutes means how many hours? 45 by 60. So this becomes T hours. So this will be your exponent, which is 4 by 3. So maps to C. Okay, how about this? I think I can get you more rigor, I feel. Let me see. How about this? Okay, how about this? Yeah, this is a good one actually. Okay, this is a good one. Let's see. How about this? Not a hard one, but send the answer to me. Is that right, Rishit? I
That was
also.
for the previous problem.
Oh, that was for the previous problem. Mm-hmm. Avni, that's right. Shrikar, that's right. Arush, that's incorrect. Arush, that's not correct. Akshada, I'm waiting for your answer. Think about this, Arush. 800 by x will be bigger, or 800 by x plus 2 will be bigger? This will be a smaller number, right? This is smaller, right?
Yeah.
So 800 by x, from that you're going to subtract 20, that you get 800 by x plus 2, right? Make sense?
Mm-hmm.
A is the answer. Now let's see this one. How about this? Okay, how about this? This is a minimal exponential problem. Let's see. Yeah, this is a good one. Shall we try this one? I don't know the answer for this one. Let's see. But yeah, these are subtle, different from the school level. The graph y equal to a b power of x passes through 0, 4 and 2, 36. What is a plus b?
Priya auntie, I can't see the full problem.
Why, ma? What is it you're seeing?
It's cut off at the top.
Oh, wow. Now?
Yeah, I can see
Yeah, I can
it.
see it.
Thank you.
But still, I don't think you guys are seeing it fully, whatever I'm sharing, because I do see the same screen. You're able to see now, ma? Are you able to see now?
Yeah, I can see it.
Okay, go ahead. Oh, I think if my screen width extends more than something, then it's a problem, I feel. Go. Let me know, guys, if you can't solve, it's fine as well. Rishit, you got it, Rishit?
I'm doing it.
Let me know if you just need help there. Okay, let me go to the next one when you're all doing this. Oh, that's a good one. How about this? Rest of you who have done it can go to the next one. Yes, Shrikar. Rishit, I'm waiting. Do you need me to do that, or you have already
Present
answered?
it.
Yes, that's right. So let's move on with the next one. The value of a stock is modeled by We can do some logs graph as well.
Wait, Miss Priya,
Yes, ma?
what's the number after since it's cut off?
Okay, yes, I can see that.
Oh,
Hold on.
2015 thing.
No. You're able to see now?
Yeah, there's like an arrow over it. It was like a tiny arrow over it.
2015, ma. There was a tiny arrow. I don't know what was that. Yeah, 2015. I don't know the answer for this one. Two. Oh, nice. Nice, Avni. Looks like it's very easy, right? Oh, this is a good one. Shrikar, that's right. Rishit, that's right. Avni, that's right. Akshada, did you get? Subi, did you get? Or you can proceed with the next one, whoever has done it. A radioactive isotope has a half-life of 15 years. Okay. If the sample currently has 100 grams, which of the following expression represents the number of grams remaining d days from now? D days from now. Assume 1 year is equal to 360 days. It's a half-life of 15 years. Okay. Oh, that's so hard. Mm-hmm. Akshada, your answer is right now. Arush. So they just want you to play with the days and years, right? So Shrikar, Rishit, did you get the answers?
I'm almost done with it.
Yeah, I'm almost done too. I think I got it.
B, that seems right. Rishit, okay. Avni, is that right, Avni? Avni, you're converting to
I read
days,
the
right?
question wrong.
Which one?
I read the question wrong. I'm redoing it right now.
Okay. You're redoing it?
Yeah.
Okay, then let me go ahead and get the other problems. Okay, let's see. Okay. How about this? Yeah, that's a good one. Let's see. This is a hard one. Let's see what you best. Oh, this is a good one. Those of you who have done, you can keep moving. Avni, yes, ma, that's correct. The intensity of sound I at a distance d from source is I equal to k by d square. If the decibel level L is this, what is the effect of L when the distance is doubled? Okay, intensity, I by I0, so what is the effect of L? Did you get that? If the distance d is doubled, that's a good question. Rishit, have you already answered for this one, Rishit?
Yeah.
Oh, wow. So k by d square, I equal to k by d square. Okay. Effect L, effect on L if the distance d is doubled. Something feels wrong. Let me see. See, the distance is doubled. That means d, this is 2d. before. That seems incorrect. How did you conclude? Many of you have concluded A as the right answer, right? Rishit, you said it's A, right?
Yeah.
Shrikar said it's A. How did you conclude?
Okay, so L is equal to K divided by D squared, right?
I sent
I
A for the last question. I sent A for the last question.
Oh, I equal to K by D square.
And if the distance of D is double, that means D is now like 2D squared.
Yeah, correct.
So I used a hypothetical of 1 as a value of D, so
That
that
makes
double
sense.
is
See,
pretty
we'll
much
substitute.
completed
That
into
all
half.
makes sense. Okay, we'll substitute in here. So, decibel level L will be equal to 10 log base 10 of, this is K by the new D, right? 2D the whole square, right? The old D is D. So, I0, the initial I0 will be K by 2D, correct? So, that would be 10 log base 10. K and K will get cancelled. 2D get, this will be 4D, this will be 4D square, right? This one will become 1 by 4D square divided by 1 by this is Amma, this is just D square. The old one was D square, that became 2D the whole square. So this will be 1 by D square. So that will be 10 log 10 1 by 4. Can one of you tell me the answer to this? Is that half? I don't think so. Can you check? Is that half? No, right? Can one of you tell me what is 10 log base 10 1 by 4?
It's about -6.
See, L decreases by approximately 6. How did you conclude, Rishit? You said after this?
So afterwards, I just like substituted it. I substituted the K and D for
Yeah.
random numbers, and then afterwards, I like noticed the difference after the distance of D doubled, and then I concluded that the L is halved.
But how am I? But I am getting decreases by 6, right? See, that's what I'm saying. This was K by 2D the whole square. The original was K by D square. So when you simplify that, that becomes 1 by 4, and 10 log base 10 1 by 4 is -6, right? Did you all get it? Okay. So the answer would be L decreases by approximately 6. Okay, let's go ahead. How about this? This one is easy on you guys. Yeah, this is a good one. Okay, let's see this one. Arush, did you get the answer for the previous one?
No, I was a little bit confused.
No,
But I got
still,
it.
but you got it now. Okay, go ahead with this one. Doubles in size every 4 hours. Okay. Initial population M minutes after. Oh my god. Each of you have different answers here. Great. Okay. M minutes after the start of observation. So it has to double. Okay, let's see. Yeah, that's right, Arush. Subhi, that's right. Akshada, that's right. Rishit, did you get it?
No, not really. Wait.
I can wait on that, but in the meantime, I can give the others a problem. See, one thing is you can substitute and see every 4 hours it doubles means if you put m is equal to 60 times 4, the value 600 has to double. That equation is right.
Yeah, I got my answer now.
Yeah, so the answer would be B, right?
Yeah.
Okay, how about this? See, this one is a good one. Let's see. This was the previous mistake you all had. Let me see this one. See that one? I want to move on to some graphing as well. Then condensation, condense and expand I want to work on. Do you guys get that? Earthquake M1 is 10 times as intense as M2. M is equal to log base 10 of I by S. This was M is equal to, okay, 10 times as intense. I stands for intensity, right? That's a nice question. Okay. I stands for intensity and M1, M2, earthquake M1 is 10 times as intense as M2. M stands for 10 log I by S. So M1 is 10 times intense. Yeah. Did you get it, guys? Or are you waiting for me to solve? I'm not sure. You have to let me know, guys, nicely.
I got confused on the second question.
Okay. So shall I solve then?
Yeah, I'm also confused on the second one.
Yeah, sure. Okay, let's see this one. How about this? So M1 is 10 times as intense as M2. So let's say the intensity is I1. This is I2. Can I say I1 is 10 times as intense as I2? This is what I have. But they want M1 minus M2, right? First, let me convert this and write down. Log 10 I1 by S minus log 10 I2 by S. I1 is 10 I2. So, if you see this, then subtraction, right? It's subtraction. So, since the log, okay, so here we come to that log base 10. You can convert it to division. So, it ends up with I2 by S divided by I2 by S. This will get cancelled. It would be log base 10 of 10 will be 1. Make sense, guys? Where it's not making sense to Avni?
It makes sense.
For the other Sharush?
I think I got it.
Okay. For that matter, in this class, I have not done the properties of logs. That might be a missing factor, but this is what it is. Coming to the properties of logarithms, right? So this one we should know. Log base b of mn. M and n are multiplied, right? I can write this out as any base b plus log base plus I can write it out as log base b of n. See, if it is multiplication, two number multiplied and we are taking the log with base b means I can add them and write it down separately. Similarly, if it's like this, there are two numbers that are divided, right? That's the same as log base b m, log m base b minus log m log n base b. So when the same base log subtraction of two numbers is involved, then I can write it out as division. So basically this is the product property of logarithms. This is the quotient property of logarithms. So here they were subtracted. They had the same log 10. So the numbers can be divided. When I divided, everything will get cancelled excluding the 10. Okay. Another property of logarithm says log base. Okay. The other property log base b. See, the other property is log of a number. If the base is also the same number, it's 1. So that is another property of logarithm. So in logarithmic functions, right, this is product property, this is quotient property. This is another property of logarithms where the base and the number are the same, then that answer is 1. So here log 10 base b is equal to 1. But before this, right, I did not tell, did we discuss how to convert log to exponents? So basically, when you think about logarithms, right, put it as an unknown function. Then when you want to convert this, right, base remains the same. 10 power of, you write it as an exponent function like this. Base remains the same. And then this becomes the exponent. This becomes your answer. 10 power of y is 1 means y is equal to 1. That's what I'm saying here. You got it? Arush, did I help you get that clarified?
Yeah.
You have not studied logarithms at school?
No, we kind of we haven't gone in depth though. We only graphed them.
Oh, I see. Okay. You only graphed. So let me go there as well. So that also helps. Let's see. Okay, now coming to properties of logarithms, right? I just wanted to quickly go over the properties of logarithms, but before that, a couple of graphs I would like to do too. Okay, logarithms with transformations is a better deal. Okay, as you all know, there are two. One is log, one is ln functions. This stands for natural log. Okay, this is called natural log function. Usually when we write log means it's always to the base 10. How do they differ? I'll tell you slowly. This one is log base e. What are these functions? Basically, exponential functions and logarithmic functions are inverses. These both are inverses. That means what? Suppose I have an exponential function 2 power of x. Now, how to write out this? This is my function 2 power of x is equal to y. So, basically, from the graph, right, how do I draw the graph? Meaning, what is the inverse function of this? So, basically, the inverse function of this is this. You see? The inverse function by graphing. What is an inverse function? Inverse function of a particular function can be obtained by reflecting the function on the line y equal to x. So this is my y equal to x line. I'm reflecting it on that line and I'm getting this function. When you inverse a function, when you inverse an exponential function, see what happens. 2 power of x is equal to y. Now I can take log on both the sides. Meaning, how do I change it to a logarithmic function? As I said, the base is always the same, right? So here I would go ahead and write it out as a logarithmic function. Arush, have you covered this in school? Writing exponential function as logarithmic function. Have you covered that in school?
Yeah.
Oh, then you know?
Yeah.
Okay, so how do you do this?
Just the inverse.
Yeah, just the inverse, but 2 power of x equal to y means how do you write that as a logarithmic function?
It'd be like 2. Oh shoot, wait. I mean, I think it's like log x, log base x, log base 2, and then x.
1 second, guys. 1 second. Okay, sorry, guys. Go ahead. Sorry, Arush. Go ahead. How do you write it as a logarithmic function, ma?
I think it was like log base 2 and then
Yeah. So the
x.
base is always the same, but then exponent will become the answer. So log base. So this is your inverse function. So this function can be written as log base 2, log y base 2. So that's what is the inverse function. Similarly, let me go ahead and erase this. I wanted to tell you the difference between log base 10 and log base e. How about this? Suppose I have the function 10 power of x is a function. So when I draw the inverse function of this, right, this is my inverse function, but here it's going to be log y base 10 will be equal to x. So when you just write log, right, it implicitly means that we are going to have a base of 10. Okay. Again, one another function is e power of x equal to y is another exponential function, right? For this one, again, if I draw the inverse function, it's going to be something like this. But then again, there it's going to be log base e of y. So that will be this function. As a result, we don't call it as log base e, but then we call it as natural log of y. We write this log base e as ln, which is called the natural log function. So basically, whenever you indicate log, it means log base 10 unless any other base is specified. But we don't write, whenever we have log base e, we don't specify it as log base e, but we will write it out as ln. So in the calculator, usually we don't have a way to find out ln. Okay, we will have to convert to log base 10 and then only we need to calculate any values if we want to. Now let's go ahead and try this one. How about this? Suppose if I have f of x is equal to minus 3 log base e, okay, x plus 1 plus 2. Oh wow, okay, x plus 1 plus 2. So this is my function. I would like to know what are the okay, I would like to know, would you be able to graph this function? Would you be able to graph this function? First of all, we have to write the verbal description of the transformation, right? What is the parent function here? The parent function is ln. The parent function is log base e function. That's the ln function. Now, verbal description of the transformation says there is this minus indicates a reflection on y coordinate, x axis, and then vertical stretch by 3, up by 2, and then left by 1, right? So usual logarithmic function is like this. Now, how did it change? Would you be able to change and let me know? So it always has a vertical asymptote, right? So how did this change? Do you want to show? Can we try? I can as well give you 2 reference points for which you can tell me how did the points switch to what. That you can as well let me know. So 1, 0 will be a point. 1, 0 will be a point. What happened to that 1, 0 point? One, 0 and e, 1, where did they go? I would like to know 1, 0, the original in the parent function 1, 0, and then what is the other reference point? 1, 0 is one reference point, the other reference point is e, 1. E, 1. Where in the parent function these two points move to what points in this transformed function? That's what I would like to know. And what is the domain and range? Do we know? That's a good one to do. Shall we try? So reflection on the x-axis of xy, vertical stretch by 3 of xy, up by 2 of xy, left by, that's nice. That's nice, Subi. But what is that point, Subi? What is this point? What is that point? What is the y-intercept? You can tell me. What is the y-intercept? If I ask you like that, then that becomes very easy.
Zero, 2. Sorry, I was on mute.
Correct, ma. What is the other point? Tell me at least 1 point or 2 points in the graph. That helps a lot. And what is the domain alone? You can tell me as well. That is also fine. If you can tell me the domain, that's great. And show me the graph, that's great. Arush, you'd be able to do this one, right? Yep. E minus 1, 1. Really? X coordinate? Yeah, E minus 1. Correct. E minus 1, 1 now. Is it E minus 1, 1? Okay, anyway, 1, 0 is correct. However, it moved. multiply by 3, up by 2, and then left by 1. Yeah. But is it not a minus? Oh yeah, 0. Okay. Arush, e comma 1, is it correct?
I said
Minus
e minus 1,
3.
comma 1.
Minus 3 plus 2 is minus 1. Should it not become minus 1?
Oh, I think I forgot the vertical stretch.
Yeah, I think it'll be minus 1, right? E comma 1. See, the original parent function's point 1 comma 0, how will it get
Yeah.
affected? See the x coordinates. X coordinates will be affected by just this. Left by 1 means this will become a 0, right? This parent function 0 is a y coordinate, so that will be multiplied by 3. Multiplied by minus 3, still it remains a 0. Up by 2 means it becomes a 2. 0 comma 2 is the point. E comma 1 in the parent function, what happens? E, it's easy to do the x coordinate first. E becomes e minus 1, which is great. But 1, right? That 1 is multiplied by minus 3 and then added 2. So that becomes minus 1, right, Arush? Make sense? Okay. Can I move on? How about this? Tell me what is the asymptote for this. 4 log 10 x plus 4 minus 3. This is my logarithmic function. Please tell me what is the asymptote and the domain. That you can message me, please. What is the asymptote? What is the vertical asymptote and the domain? Not a hard one. Not a hard one though. Both are easy as soon as you see this, but if you are not able to, let me know, then we can discuss. Yes, ma. Oh wow, Akshada, very nice. Subi, was that the answer for the last one, right, Subi?
Yeah, not for this one.
Okay. Akshada, that's correct, ma. Shrikar, that's correct. Rishit, are you able to say?
My chat isn't working. I'm like typing it, but it's like the enter key isn't working.
No
Sorry.
problem. Can you shout out, you think? What is
How's
the asymptote? See, our
negative
usual, negative?
3.
Negative 4, Emma, x.
Yeah. Oh, the x asymptote.
Yeah, negative 4 is the vertical asymptote, and then the domain would be minus 4 to infinity. Make sense? Okay. So now, you guys are good with finding. Okay. Coming to properties of logarithms, I really want to cover just the properties and let you go. I'll just put out the properties. Okay. So product property we already discussed of logarithms. So log base b, I can split it out and write like this. Okay. Similarly, if it is in division, I can write it out as subtraction. We'll do some condensation, some condensing and expanding next week. And then I'll do more of SAT problems for 1 week or 2. Okay. After that, we can get started with pre-calc. Let me see. Log base b of n. So this is the first property, second property, and I already told you log b to the base b. Same base and same number is always 1. Yet another thing is, suppose if I have log base b a power of m, right, meaning a number to the power, right, the number can be brought back m log a base b. This is how I can write. Okay, this is 1, this is 1, and log base b, this one I want you to know. Log base b, see, log base b of 1. Log 1 irrespective of bases is always 0. Okay, log 1 base b irrespective of the basis is always 0. Okay, and let me put this up and then we will do it next week. Okay, as I said, this is the power property. This one is power property. This one is the power property. This one is the power property. Let me write it down. I don't want to write the power property there. Okay, this is not a common one. Power property says log base b m power n. So that I can write it out as n log m base b. Okay, and then the last one is, this is very important, guys. If you want to change the base, right? If you want to change the base, this is what comes handy. I want to change the base to b. Okay, then I will write log a base b, this number. Again, I'll bring that whatever base I need to write, and then log c base b. This is the most important one of all. Changing the bases of logarithmic functions comes very much in handy. Okay, so basically there is a number a. I'm taking log a base c. That I'm converting everything to log base b. How do I convert it? First I go with log a base b divided by log c base b. Okay, so we'll discuss these properties next week. Expanding and condensing, we'll do a few problems. Then I'll switch to, but this week I'll give you more problems on, I'll give you 2 assignments. Whoever wants to do the book problems, do. Otherwise, please practice for the SAT type problems. I'll give that as a part of homework, which will cover exponential, rational functions and logarithmic functions. Any questions? Any questions? Okay guys, I'll stop here.
Thank you.
I'll stop here. I'll see you all next week.
Bye.
Bye guys.
Thank you.
Priya,
Bye.
Thank you.
Bye, Miss Priya.
Bye ma. Hi guys, how are you all? Shriya Ashruta.
Hi, Miss Priya.
Hi ma. Give me 1 second guys, I'll also do this. Share. 1 second, guys. Okay, I'm here. Ashita, when is your exam, ma? Geometry Friday. When is your exam, ma? Okay. So we have completed. So probability is what is remaining, correct? Okay, guys. How are we coming along? We'll get started, guys. How are we coming along? Shriya, Ashrita, Diya, Avyut.
Good.
1 second. Actually, were you able to do the 3D solids? Were you able to do the 3D solids, ma?
I'm almost done with part 2. I didn't really get to start part 3.
But do you have a question? Do you have a question on that?
No.
Okay, you are able to understand whatever is given. Okay. Okay, then let's move on. Any questions, Shriya? Did you have any questions? Did you try the homework?
Like, I did it, but on a scrap piece of paper because it was kind of already done on the PDF.
Not everything was done on the PDF, right? Or you can always message me. 1 second, I want to go back to that. Usually it is not done on the PDF. See, the problem is a kid might have done it on the original piece, I feel. Let me see. I just want to make sure on that. Volume 2, solids. Let me quickly check, guys. Okay. 1 second, I'm checking on that. Geometry Friday classwork. Volume 2 solids was given earlier.
Miss
Okay.
Priya, wasn't it homework volume part 2 and part 3?
Volume 3D
3D
solids
solids part 2 and 3, right?
from part 6 till end, right?
Oh, because it said part 2 3D
Yeah.
solid.
Part 2, part 6 till end is what is given, right? There is, see,
Oh.
volume 3D solids is split into two different pieces. Part 1, part 2, let's say. Okay. In part 2, there are several subparts. Am I making sense?
Oh, but where is part 2 posted then?
It is there in the classroom, so I did not again post it. That's all.
Oh, okay, because, oh, is it the 3D solids part 2?
Yeah, exactly.
Oh, then I did the wrong thing.
But I want you to do 6 to end because though,
Okay.
hey, Shriya, it's not already done, right?
That one, I was talking about the part 1, and then I got confused as to the other one because there was no PDF for it.
Part 1 you did?
Like, yeah. But separately. Because that one had the writing on it.
Part 1, okay, let me share. Can you share screen and show me? Because I'm not seeing part 1 is done. Can you share screen and show me what is done?
Part 1 has answers on it. Like, the kid did it.
Do you mind sharing my? I just want to see what you're all referring to.
Do you want me to? Oh, she shared.
It's been erased, like, somewhat, but earlier in the week on Monday and Tuesday, the full answers were there. So, yeah.
Oh, the full answers were there. So Amma, it is great if you can see, Amma, the way to submit the homework is you can even do it in your rough notebook and put the PDF up there, right? Meaning I have no idea as to how you're doing the homework, right, Ma? So I need to understand how you guys are doing the homework. So the only way is when you submit it. You see what I mean?
Miss Priya,
Yeah, Ma?
if I think I erased the answers accidentally, thinking that I went to some other PDF where I changed this into a Lumen PDF and then I erased it. I didn't know that would erase on the real
Oh,
one.
no problem. But see, what you did was the right thing to do. Okay, Avyut,
Oh,
so
okay.
nice owning it, first of all. Okay, but
Okay.
no, there is another kid that by mistake wrote it. Okay,
Oh,
so what
okay.
has happened? I'll tell you the whole story. I'm glad you went ahead and erased it. Okay, honestly talking to you. But so nice of you to come up with the fact that you erased it. Okay, first of all, it is in editor mode for all of you. I'll have to stop that. Okay. The thing
Okay.
is, some other kid went ahead and wrote the answers. Okay, what you did, you went ahead and erased. Very nice of you. Thank you.
Okay.
Okay, but the thing is, I should not have let you edit it at all, you guys. You got it, should be in viewer mode.
Okay.
That is why that I always request you to download the PDF, upload it to your Lemon PDF, whatever you want you do. Make sense, Ma?
Yeah.
Yeah, so nice of you, Abhyukt. But did that answer your question, Shreya? It was he who went ahead and erased it. So nice of him. You got it. But Shreya, I would really like to see your homework submitted in Google Classroom. Makes sense there. That's my only way. And one more thing, are you checking with the answers? Are you getting it? Those all are on your head. You're all high schoolers, right? At least late middle schoolers. So I would expect you to cross check with the answer key, come back and ask questions if you don't know. Okay, so let's move on now. Okay, where are we? Okay, let me review part 2. Pratika, what are you doing in school, ma?
Algebra.
You sorry. I should not have asked you. Ananya, what are you doing?
We're doing what's it called? Circles still, but we're kind of doing like more of like tangents and secants
Is
and
that easy?
yeah, for the most part. I got 100 on the test.
Okay. How about who is learning? Who is not learning geometry? Vinisha, how about you?
We just finished doing circles. Like,
I see. I see. So have they already completed 3D objects or are they doing it now?
I think they're about to start it.
Okay, and we discussed surface area volume ratio, right, guys, last week? Did we discuss surface area volume ratios? No, yes. Please answer, guys.
I don't think so.
Interesting. Okay. Okay, how about that? Okay, interesting. Let's see. Let me then review a little bit of this because I am not sure. Let's see. I feel like I'm lost. Okay. I want to compare. So, how are these volumes different? Meaning, I'll give you two solids. Number 1. Number 2 is this. Okay. Number 2 is this. How are the two solids volume? How can you compare the two solids volume? One is 2 times the other, one is 3 times the other. Can you let me know? It's an easy question, right? You know how to find out volume. I'm just asking, how do you compare the two solid volumes? That's all.
Is the second one 3 times the volume of the first one?
Yeah, that's all. That's all I wanted. So here when you think about it, this is r times r times r, right? So this is the first one I'll do. So this is r cube This one is 3r times r times r, 3r cube. So when you compare, right, r cube is the old volume. So this is the old volume. So this is equal to 3 times the volume of the other one. This is the comparison I wanted you to make. So let's go ahead and try this one. Okay. Now let's go ahead and try this one. Yeah, this is a good one. Not really. Hold on. How about this? Okay. How about this? Can you do this one for me? Volume comparison, let's see. How about this? A can of tennis balls has an inside diameter of 7 centimeter and a height of 20 centimeter. The diameter of the tennis ball is 6 centimeter. What is the packing efficiency of the tennis ball can? That is, the 3 balls represent what percentage of the volume of the can? A can of tennis balls has an inside diameter of 7 centimeter and a height of 20. The diameter of a tennis ball is 6 centimeters. It's so messy a question. It is just that there are 3 tennis balls inside the can. That is very clear. Okay. The 3 balls inside, it represents what percentage of the volume? Would you be able to tell me? You have to compare volumes. You have to find the volume of the ball. You have to find the volume of the can. Guys, you have questions or you think you can go ahead? You have to ask them up, please.
The volume of the can is 38.48.
Volume of the can is?
Oh, 30. I got 38.48. Oh, no. Sorry. I forgot the, the volume is 769.69.
So much better. That's right.
Yeah, sorry, I forgot to times the height.
Yeah, go ahead and calculate the volume of the ball and tell me what percentage of the volume of the can is the volume of the balls.
Do we know what the height of the tennis ball is?
It says that there are 3 balls, right, ma'am?
Okay.
And then look at this. It's a cute magazine. Did you not come to Harshita? Perfect, ma'am. Ananya, what is that you have given me, ma'am?
I think I did it wrong.
Yeah, I think so too. See, guys, you should be able to compare volumes very well if we finish this. Shri, I'm also waiting for your answer, ma'am.
Miss Priya, I don't know if that's right. Can you check my answer?
Yes, ma'am. Your answer was correct, ma, Harshita. You want to explain to us? Okay, Shri, give a minute. Okay, Shriya, how did you do?
I
Avyuk?
sent you the answer.
I
You
got
got
the
my
answer. Could you check mine?
yeah. One second. So let me quickly check. This is 113. There is Zoom. Not really, ma, Ashriya. Not really, Ashita. Dhruv, not really. Vinisha, that's correct. The percentage part is the volume of 3 tennis ball divided by the volume of the can, ma. That's all. You got it almost. Vinisha, did you understand? There are 3 tennis ball inside a can, ma. They're asking for the percentage ratio. Percentage of the volume, percentage is the volumes of the 3 tennis ball divided by the total can's volume. Whatever you found is correct. Your values are correct. But there are 3 tennis balls. So find the 3 times that each ball volume divided by the total volume. Correct, Avyuk?
Oh, okay.
Okay. Avyuk, do you want to explain? Or Harshita, do you want to explain? One of you explain. Shriya, did you get it?
I sent it. Can you check it?
Ah, I saw then. Yes, that's good. Yes, go ahead, ma.
So I found the volume. I found the volume of one tennis ball, which is using the formula of 4/3, which is 3 cubed by which equals to 27
Mm-hmm.
times pi.
Mm-hmm.
And then
6 centimeter diameter 6 centimeter. Okay.
I multiplied that whole thing by 3.
Mm-hmm.
And then I got 339.29.
Mm-hmm.
And then
39.29.
and then I found the volume
Volume
of
of can.
the can.
769, right?
Yes,
Uh-huh.
769.69.
So the percentage volume is 39.29 divided by 769 is a decimal. So what do? Multiply by 100, divide by 100. So this division by 100 you can take out and replace it with a percentage. That will be 44%. Make sense? Thank you, Avyut. Okay, let's move on. So comparison of volume, not a problem. How about this? Congruent similar solids, I don't know whether we did. How about this? really wanted to be able to compare. Then compare the two figures. Okay. How about this? Okay, you're going to find the volume of this. Okay, I'll give you the solids. You're going to compare the volumes. Okay, this is my first solid, and then this is my second solid. You're going to compare their volumes and tell me. Okay, which is bigger? Let's see. This is a little tricky. Let me see. A teeny tiny bit tricky. It's not very tricky. Go ahead and try this one.
Wait, do we tell you which one has more volume?
Compare their volumes.
Oh,
And did we tell you which one's bigger or both of them?
You're just going to compare their volumes, how they are different.
How?
for example, would we say
For
like
example,
the
you
cone
say
is like
8 times bigger, or or just tell me what are the two volumes and bigger or smaller, which is bigger. That is enough.
In chat?
What, ma?
Oh,
If you
I
just
just
say which
asked
is bigger as well, it's great. But I want to have the expression of volume of both. And which one is bigger.
Okay.
You get it? Um, wow. Which is bigger, Mashriya? You're muted. Oh, nice. Okay. Yeah. Pyramid is bigger because pyramid will be bigger. Dia, did you get it?
Yeah, I'm
Wait,
almost
Miss
done
Priya,
solving it.
Uh-huh.
Miss Priya,
The second one is
would it is it bigger because like the base is equal to 4r square and
basically this would be 2 pi r cube. This will be 8 r cubed. What is 2 pi? 2 pi is 6.28, right? R cube. 6.28 times r cube. This is 8 r cube. Which is bigger?
the
Am I making sense? No
yes.
problem. Yeah, that's all. You had a clarification. Absolutely fine. Okay, now let's go ahead and try a couple of other questions. I don't want these easy ones. We can take these of comparing volumes. You seem to be good. Okay, how about this? This is a little tricky one. I would like you to try though, but that's easy. Okay, how about this? Volume of a stone, that I would like you guys to do. Let me see, guys. Give me a minute. This is a good one. You're going to try. Okay, volume, the base concept you know, but this involves a little bit of thought process. Okay, let's see. I don't know whether I have done this with you guys. Okay, first let me see. Let me give you an easy problem and ask you. See, suppose if I drop a stone, right? Let's see. I don't know whether I have discussed this with you. Okay, basically the concept is this regarding, this is related to, see here, there is a prism, there is some water in it, the dimensions are 10, 15. This is before. After what I do, I place a stone inside it. What happens is, the height of the water increases by 2 centimeter. That means, what is the volume of the stone dropped? That the volume of the stone dropped is equal to the volume of the stone dropped. Here, volume of object will be equal to the volume of displaced water. What is displaced water? What is the displaced water? The water rose by 2 centimeters, right? That height 10 by 15. So volume of that object dropped inside the prism will be equal to the volume of the displaced water. Any questions here?
So would we add it? Or do we just say 2
How do you,
centimeters?
okay ma, there is a big stone. How do you find the volume of the stone? There's no way, right? So in science labs, how do they find the volume of that stone? They put that into the water. It will make the water rise up, right? This volume of water that rose up is called the displaced water. It changed its place, right? Displaced water. The volume of that displaced water will give you the volume of the stone. Make sense?
Oh, okay, so it would be 2 centimeters in this case.
Height is 2 centimeter, but the
Oh,
volume you
okay,
need to
okay, okay,
calculate.
then we found one.
Yeah, you got it? Okay.
So is the question just asking us like just to find the volume of the rock? That's just like,
Usually, yes, volume of the solid, because it's very difficult to find the volume of a solid that does not have a proper shape like a prism or a pyramid, right?
okay.
That is when you use this. This is a very nice concept as well. Okay. Now, let's see this one. I'll give you an easy question first. I don't want to mess right off, but at the same time, I want you to try. Let's say. Let's see. See, the volume of displaced liquids is very important actually. Try this one. This is an easy one, but I want you to try one easy, one hard problem in this. Okay, the concept is the same. Try that one. The concept is the same. I'm going to help you. If you don't. The second one is a little harder, which can make you think. That I want you to do. Two questions, guys. Second is definitely relatively a harder one. Only thing is you need to understand the concept of it. Let's see. I can do it on the board as well, but second one, if you can get it right, I'll just move on. I'll not even think of redoing anything. Let me know, guys. Let me know if you need help.
Miss Priya,
Yeah, ma.
for the first one, it doesn't tell us the height, right?
For the second one?
The first one.
For the first one?
Yeah.
You have to tell me again. What was that for the first one?
For the first one, it doesn't tell us the height, right? It just says base measures 15 by 15.
Oh, it doesn't tell the height, really?
Well, I'm asking.
Let me see. Rock is added to a container of water and it raises the level of the water by 3. It doesn't have to, right? It's asking only for the volume of the rock.
Okay. Yeah.
You see what I mean, huh?
Yeah.
We are not finding the volume of the container. Only when we
Yeah,
ask
okay.
for the volume of the container, you need the height.
Okay, yeah.
Yeah, go ahead. But good questions.
Yeah.
Yeah, ma.
Can you check my answers?
Absolutely. Avyuk, that seems right. Pratika, that seems right. Vinisha, that seems right. You can continue with the second problem, guys. Dhruv, I'm waiting for your answer. Diya, first one, did you find it, Diya?
No, I'm still doing the first one. I just tried like the second one
Ananya,
first.
I'm waiting for your answer. Harshita, the first one is right. Second one, I'll check, ma. Second one, the answer is correct, Diya. Good job. How did you do that?
I just did like I found the volume of the chest, and then I did like since it's rising 4, so I just like multiplied it by 4. And I did like 1/8, so then I found out what
Very
7.
nice. Good job, lady.
Yeah.
See, if you conceptually understand it, it's easy, right?
Yeah.
Yeah, nice.
Miss Priya, am I right or am I wrong?
Which one, ma? Yes, you can go. Harshita, you got both, huh? Wow. Dhruv, correct. Vinisha. Yeah, I can do the second one on the board. Okay, who asked me whether they are right?
Me.
Pratika, correct, ma, both. Ashrita, the first one is correct, but the first one is not centimeter, Ashrita. The unit is different. Water level rises by 3.
Cubed, right?
Yes.
Okay.
675 centimeter cube. Then a block of ice is placed into an ice chest containing water. The ice causes the water level to rise by 4 centimeter. Okay, the ice chest measures this. Okay, when ice floats in the water, 1/8. See, the problem is when I put the ice in the ice chest, right? So 1/8 of the volume floats above the water. See, 1/8 of the volume floats above the water. So basically, the rest of the part, 1/8 is above water means 7/8 of the volume of ice is the volume of the displaced water. What is the volume of the displaced water? 35 times 50 times 4. Any questions, guys? So volume of ice will be equal to 35 times 50 times 4 times 8 by 7. Avyukt, are you with me, Avyukt?
Yeah.
20. So that will be 1000 times 8. That will be 8000 centimeter cube. Any questions? Shriya, did you get it, ma?
Yeah, I sent it to you earlier.
Wait, I did not see your answer, lady. Good, Shreya. Nice. Okay. Now, let's go ahead and try. So, comparison of volume, displacement is done. And then what else needs to be done? Yeah, this one you should be able to answer this. I'm not going to do this, guys. This one is so easy one. Or maybe one problem in this I can do. See, this one, would you be able to tackle? This is just volume, but slightly twisted volume. Let me see. Volume, all volume I know you guys will do. But a chocolate cake of diameter 24 centimeter and height 14 centimeter has a slice missing whose vertex angle is 45 degrees. Do you think you can do? Do you think you can handle it, guys? So volume of the cake is what it is asking.
Well, I got the volume of the cake.
What is it now? Volume of the cake is what I want.
So like with that, so with the slice missing? Or
Yeah.
okay.
Miss Priya, can you check my answer? I sent it in the chat.
Yes, ma, I have it. Yes, ma. Shreya and Avyukt, you got it. You think I can move on? Ashrita, for some reason your answer is a little bit off, Amma. I don't know what is that's off. Shreya and Avyukt had exactly the same answer. Yours is 7 or 8 less.
Miss Priya, can you do this one on the board? Because for the whole cake without like this last part, I got 6,333.45.
Okay, the entire cake is 360, right? Right? So
As in
360 degrees,
degrees?
right? The entire
Oh,
cake is 360 degrees, right?
yeah.
45 by 360 is missing, means what is the rest of it? 45 you subtract, right? What do you
Mm-hmm.
get? 315, right?
Uh-huh.
So 315 by 360 of that volume, right?
Oh, okay.
Does that sound good?
Yeah, and then 315 over 316 of 6,333.45, and we get the answer.
Yeah, so other, see, yeah, you can do that, yes.
Okay.
Make sense? Make sense, ma'am?
Yeah.
Okay. Can I move on? Yeah, I think we are good on that. Let's see. Volume comparison. Yeah, see, I did not complete this one, guys. I did not complete the surface area and volume. Okay, Coming to congruent and similar solids, right? Congruent solids are solids that are exactly the same. Similar solids vary in their size, but the shape is exactly the same. Okay. Now I want you to do a quick exercise and learn things by yourself. I'm going to give you two prisms. Okay. The exercise seems very easy, but the takeaway is something you're going to completely learn new. Okay. So now here I'm going to give you two similar solids. Okay. What you're going to do is, let me show you. You have the two similar solids. What you're going to do now is, you're going to find the solid's surface area and volume. The solid's surface area and volume. Here you're going to find out the solid small, big. You're going to find the ratio. This table you're going to fill in and come up with the takeaway. Okay, this is a big learning actually. So these are similar solids. We are working on similar solids, but we are trying to understand something. So now you're going to find the surface area of the small, surface area of the big, volume of the small, volume of the big. Then you're going to find the ratio between the two. Okay. So now surface area of similar solids. What is the ratio? Surface area, volume of similar solids. What is the ratio? I just want to know. Can you go ahead and try? Can you go ahead and try? Let me know if you need help. You will come up with the takeaway. I don't need to help you. Did you finish? Let me know if you need help there. Done, guys?
Miss Priya, I'm almost done.
Yeah.
Miss Priya, what do you want us to put in the chat?
No, I just want to discuss with you guys this one. Make sense?
Oh yeah, I'm done.
Yeah. We'll discuss. All of you are done?
I'm done.
Okay. So let's go ahead and try. What was the ratio here?
2. Well, scale factor of 2.
Small by big, right?
Oh yeah, 1 over 1 by
1
2.
over, huh?
1 over 2.
Was it 1 over 2 for the others?
I got 1/4.
That seems right.
Isn't it? Cause okay, I think I just wrote scale factor.
Okay, so that was 1 over 2. Shreya, what did you get for the volume ratio, ma?
1 over 8.
So can I write it out as 1 over 2? So the scale factor between these two was 1 by 2. For every one, there was a 2 here. So what does it say? Surface area ratios will be the scale factor ratios the whole square. Volume ratio will be the scale factor ratio the whole cube. Does that make sense? When you want to compare the surface areas of two similar solids, then the ratio of their surface area will be whatever the scale factor is, you have to square them. Whatever is your scale factor ratio, you have to cube them to find the volume ratio. Does that make sense? Okay. That's the takeaway. Okay. Now that you learn by yourself, I am thinking it will help you retain. Okay. Let's see. Let's see. We'll do one or two problems in this. This one is a common. Okay. How about this? Yeah. Try this one for me. Let me know if you think it's hard. So from next class we'll do only probability. Okay, all types of probability we'll discuss.
Miss Priya.
Yes, ma?
So like 3D shapes and solids and like all the shape stuff. Is that all gonna be on the second test?
Come again?
You know, like 3D shapes and 2D shapes and all of like polygons and all of that stuff. Is that gonna be on the second CB or the first CB? Like part A or part B?
I need to check. I don't remember. Definitely circles is on the second one that I know. See, the main problem, circles is on the second one.
Okay.
Okay, with respect to your algebra 2, the kids that took algebra 2 this year, right? What they suffered the most was part 2. What happened was the first part had only 47 questions. The second part had 75 questions, double the amount, but the same number of, but the same time. So the kids that can get 100 out of 100 did not attempt 5 questions because they went, they were crunched for time. You see what I mean?
Wait, yeah, wait.
So they did very well overall. Okay, scores were all 95 plus. That's all fine. But then, meaning they can really get 100 out of 100 in algebra 2 and all. It's very easy in both to get 100. But the thing is, it was so bad. The first paper was 47 questions. They had the same
geometry, right?
Not for geometry. This was for algebra 2. I don't know what will happen in geometry. We have to wait and see, right? You guys are going to take, right? Or was there somebody who took? I need to verify. I don't think so. So whenever you guys take it, right, be very, very, very wary of time. Okay, I have posted a EOC test, right? Make sure you keep up your time given. Time yourself and do the mock tests. That will be problematic for jump because you guys are not used to time-based tests. That's where SAT also becomes tough. Okay, maybe you know all the concepts, but if they crunch for time, then yeah, it's a problem. Make sense?
Okay, yeah, wait, but for geometry, is there a chance that would give us 75 questions in 3 hours?
I don't know, ma. It depends on the ISD, ma. It is not a
Oh,
common paper. You see what I mean?
okay.
Nobody is going to give you a common paper that's common across all ISDs. Make
Okay,
sense?
yeah.
So it is entirely depending on your ISD. The teacher who sets the paper sets the number of questions in each part.
Okay. Also, Miss Priya, does class start at 7:15 or 7?
7:15 or 7. Actually, I don't know. What was in the welcome email?
I'm not sure because before I used to be 7:15, but today I joined at 7 and like I joined but like class start at 7:10. So
Can I check?
yeah.
I don't know, honestly. I'll have to check. Okay, I can check on that. Let me check. Class starts at, okay, first let me give you some problems, okay? Did you finish this problem? Find the surface area of a similarly shaped box that's smaller by, okay, I did not check the answer for this one, right? I was just talking to you guys. Ananya, that's right. The others, did you find out the answer?
I was kind of confused. Do we just divide by 3 for this to find the answer?
Divide by 3. Not really, right? The scale factor is 1 by 3. So what do you do? Scale factor is 1 by 3. They want you to find the surface area. For area, what is the ratio of their areas? See, ma. Okay. Let me go ahead and show you. Scale factor small by scale factor big, meaning I'm sorry, scale factor, okay, ratio is what we are discussing, right? So we are discussing small by big, right? That is 1 by 3. Okay, now surface area, these are similar solids, surface area ratio will be 1 by 3 the whole squared. Volume ratio in this case of these two similar solids will be 1 by 3 the whole cube. This is the learning we learnt. But what they have given, the surface area of a box is 1800. Find the surface area of a similarly shaped box that's smaller by a scale factor of 1 by 3. So they have given the big box surface area. So you know surface area ratio is 1 by 9, right? That is small by big. Small, we don't know the surface area, which is what you need to calculate, okay? The bigger one is 1800. So they are asking what is the surface area of the small box. So surface area of the small box, right, will be equal to 1800 by 9 will be equal to 200 inch square. Make sense?
Oh, okay, I get it now.
No, that's a tricky one. But you know, I really want to finish the last one as well. How about this? Okay, now guys, see, the way I want you to understand one more thing about volume is if we change the dimensions, right, how the volume is going to change. I'm coming to the class time, okay? I did not have time to check when I'm discussing with you. I'll come back on the class time. Now, let's say I have a rectangle. Okay? If you double the length, what happens? I have a rectangle. I double the length. So, what happens? What is the effect on area? Who can tell me what is the effect on area?
It doubles.
It doubles. Good job. So LW becomes 2 times LW, correct? Okay, so here what happens? I have a circle. You triple the radius. What happens?
The area triples.
No. Class time is 7:05 to 8:05 Friday CT. Make sense?
Thank you, Miss Priya.
No problem at all. But what happened to the circle? So let's say the original circle. Original circle is pi r square. Okay. I triple. Okay, now new. New is I triple means instead of r, I make it as 3r. So what happens? Pi times 9 times r square, I can write it out as 9 pi r square. What happens to the area? What happens to the area? It becomes 9 times the original area. Do you get it, guys? Yeah, that's what I'm saying. So you should be able to clearly tell if I change the dimensions of a solid, how will the area be affected? Okay. Now, how about this? You're going to answer this one. Please, I'm expecting you. This is only 2D solids. Height, area of a triangle is half BH. Height and base are increased by a factor of 6. You guys tell me, please. You substitute, find out, tell me. What happens to the area? I'm going to wait.
Miss Priya,
Yeah.
I think is the question D base? Oh, okay. Yeah, I saw only a little bit of it.
You got the answer?
No, I was saying I saw only a little bit of the question, that's why.
Oh.
Are you asking how much the area is?
Yeah. How does the area change?
Okay.
See, I have to cover solids as well. Another 2 to 3 more minutes I'll take them. I need to really understand how the volume as well changes. So, meaning for 3D solids as well. So, let's see. Go ahead and do quick. Got it? I am waiting for your answers. If you're not getting it, quickly tell me. Shriya, is that right? Are increased by a factor of 6. That's right, Ashrita. Do you want to redo Shriya? Did you get it? Can I help? Harshita, that's right. Shriya, that's right. Avyukt, it is 36, right, ma? Vinisha, that's 36, ma. I'll tell you why, guys. Area is half BH, the original. This is original. Okay? Half BH. Oh, wow. Okay. Now, original is half BH, right? Height, base is increased by a factor of 6. Height is increased by a factor of 6. So, what happens? Half 36 BH. I'm sure I'm going 36 times half BH. So, that will be this is the original volume. This is your original volume. So, 36 times the original. Make sense? Make sense?
Miss Priya, I'm confused.
No problem. I'll go ahead and do. Where are you confused?
On the last step, why did you like put it? Why didn't you like combine the whole thing and stuff like?
Avya, please ask again. This is your original. Did you understand that?
Yeah,
Now in the new, the B became 6 times B, the H
yeah,
became 6 times H, correct?
yeah.
Now I combined the numbers, wrote it down as 36BH, right?
Mm-hmm.
But you know, this can be taken and plugged in as original volume, correct?
Yeah.
So I plugged this as original volume, so that became 36 times original volume.
Oh, so we read the original volume and then the formula?
Yeah, you always replace the original volume so that you understand the relation, right?
Okay, I got it.
Does it make sense?
Yeah.
Okay. How about this? I'll do 2 3D shape and then let you go, guys. Okay. Let's see. 2 3D shapes I have to give you, right? Let me see what I can do. 2 3D shapes. Okay, let's see. How about this? A rectangular prism, okay? Triple the width and quadruple the height. Rectangular prism, triple the width and quadruple the height. Rectangular prism, triple the width, quadruple the height. What happens to the new volume? Compare with original volume. Should be able to compare the You get it, guys? We'll finish with this, guys.
Miss Priya, do you want us to tell you how much the volume increases by?
Yeah.
Okay.
If you do this, I'll let you go. Okay. Rest of it you can do at home as well. It's okay. Let's try. I didn't mean to take your time, but at the same time, just making sure you're getting it. Should not be that hard, I'm thinking. Let's see. Yeah, ma. Vinisha, you already answered yes, ma, Avyukt. Correct.
Miss Priya, is my answer right?
Avyukt, this is LWH, right? The original volume is LWH, correct?
Yeah.
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 So whatever you've written is correct. Shriya,
So
correct.
both of them?
No,
Both
no,
of them
no.
are correct?
See, the original is LWH. The new one is
Okay.
12 times LWH. So,
Okay.
how did the new volume change? 12 times the original volume.
Okay.
Make
So I
sense?
see. I see now. Okay.
Pratika, did you get? Yeah, everybody got it. Can we stop here, guys? Next week we'll do only probability. Okay?
Okay.
Yeah, I think we are good. Okay? Okay,
Bye,
guys.
Miss Priya.
Bye, guys.
Right.
Bye, guys.
So
Bye,
this week
Priya.
we're gonna get homework over this, right?
Yeah, ma, I really want you to finish the 3D solids
Okay.
part 2 booklet.
Okay, I'll write it down.
Okay.
Thank you, Miss Priya. Bye.
Bye, ma.